Welcome back to our next installment of our ecology unit. Today we're going to be focusing on energy flow, and energy flow is the idea of energy moving through the trophic levels, usually starting with the sun and ending up at whatever the apex predator or top consumer is. We're also going to be looking at how energy is lost along the way. So like I said, the source of energy almost always is the sun. Most autotrophs get their energy from sunlight, although some, as mentioned in the previous lecture, get it from chemicals when they do chemosynthesis, but typically the autotrophs that we're concerned about go through photosynthesis. Again, this is old hat for you, hopefully, but energy flow the energy moves through food chains by means of feeding. So you're going to always start with producers, and they're always going to have the most amount of organisms within that trophic level, and then go to primary, secondary, tertiary. And many times there's not much more than that because there's just not enough energy to sustain an additional trophic level beyond a tertiary consumer. Food chains and webs, this is just a review. Hopefully you know this. A food chain is a linear representation of how energy is transferred between species, whereas a food web shows multiple food chains together and how they're linked. And it also helps show how certain organisms may have more than one predator, or they get their energy from more than one source. In this case, and you can see it with the turtle, the snake, the frog, the kingfisher, you'll notice that they exist in multiple trophic levels, so they could be a primary, a secondary, a tertiary consumer, depending on what food chain you're following. Ecological pyramids show up kind of a lot, not a super lot, but you need to be able to understand the different types of pyramids that show up in different exams or exam questions. So there are three types of pyramids that we're going to focus on. So the pyramid of numbers, of biomass, and of energy. So the pyramid of numbers literally shows how many of each organism is at each stage. So of course, you're going to have the biggest amount of organisms in the producer level just because they have to get the energy to sustain the rest of the pyramid, so there's always going to be more there. The pyramid of biomass shows the total amount of mass at each stage, so similar to numbers, but you'll notice in the image here that you have a tiny little piece of the pyramid underneath, and these are your decomposers for numbers because they bring the energy back into the rest of the rest of the ecological pyramid, whereas over here you don't have that because you're not using numbers, you're just using biomass. And then the last one is the pyramid of energy, and that shows how energy is moved between each of the trophic levels. And you'll notice that this is a very different shape than the other two pyramids, and typically it's shown as accurately as possible. So because energy, you only get 1/10 of the energy that would be in the producers in the primary consumer level, you'll notice that it's significantly smaller, and as you continue up, the pyramid levels get smaller and smaller. So again, energy pyramids, this is where we're going to focus most of our attention on. Although the other pyramids exist, energy pyramids are typically what you see. So the units that you use is the amount of energy per area per time. So in this pyramid, they will never appear inverted because energy is always lost, so it's always getting smaller as you go up. It never gets bigger as you go up. You never get more energy than what was available on the level below you. And again, each level should be about 1/10 of the size because you only get 10% of the energy from the previous level. I will say that IB is super strict about this. They really, if you are going to draw an energy pyramid in one of your answers, if it is not drawn to scale, aka each level is 1/10 of the size of the preceding level, you will be marked wrong. So something to think about. Now, energy loss, most of the energy is lost in a trophic level through heat. So, as organisms go through cell respiration or other just general metabolic processes, a byproduct of all of that is heat, and that's where most of the energy is lost. But some energy is also lost by excretion, or you don't eat it all, right? Like if you are eating a chicken wing, like I don't also eat the bones, and so I'm not getting all of the energy that that chicken wing could have provided me, but I'm getting most of it. This is a good representation of how energy leaves as you go through. So starting at the top with solar energy, that solar energy will get absorbed by producers, and then the producers will get eaten by primary, then secondary, then top consumers, whatever that food chain may be. But you'll notice on each of the trophic levels, so each of the green boxes, the different shades of the green, you are losing energy on both sides, whether as heat or as chemical energy. Eventually, all of the energy that is left will be going through the decomposers and then released either as the nutrients will get cycled back in, or the energy will get lost into space as heat. So talking about energy efficiency, it's like I kind of mentioned with the chicken wing earlier, energy transfers is never 100% efficient. Most of the energy that you get from the start, so like most of the energy that you would get from the sun is lost to the plant, and then only a fraction is passed on to the next level. So this is why you cannot have a never-ending food chain, because as you can see in this picture, if you start with 100 liters of energy and you only take 10% as you move through, by the time you get to the this top predator here, you only have 1 milliliter of energy left, which is why when you're looking at the like number of organisms in a pyramid, the top is always super tiny because there's just not a lot of consumers that can survive in a group with only this amount of energy. And so again, talking about biomass, is a total mass of a group of organisms, which is again why it gets smaller, because there's fewer and fewer consumers as you move up the pyramid. And so as energy is lost, the higher levels don't get as much energy, so they have less biomass because there's just not as many organisms in there. This is again why you can't have unlimited organisms in a food chain, because it's not worth it to be in that food chain, because it's just, you'd have to do way more work to get enough energy than the reward would give you. So it's not worth it. And then the last bit for today is talking about biomagnification, and it's mostly talking about pollutants. So if pollutants get into the food chain, they will build and it will become more concentrated at higher trophic levels. So the two main terms here are bioaccumulation and biomagnification. So bioaccumulation is the increase of a substance in particular organisms' tissues. So let's look at this first picture here. So in these, let's say that they're plankton. The plankton are eating some toxin, whatever it may be, and the accumulation in the plankton is happening in their own tissues. But biomagnification is more what we care about, because we're not eating plankton. But this second primary consumer, the second fish that's in this food chain, is eating a lot of these plankton, which means that the concentration of the toxin, whatever it may be, is increasing in this primary consumer. In this secondary consumer, they're eating a lot of the primary consumer, so the biomagnification, again, the increase of this toxin is now going up again in the secondary consumer. And then by the time it gets to tertiary or apex predator, the biomagnification is much larger because the concentration has increased at each trophic level. Okay, so hopefully that made sense. Thanks for tuning in. I'll see you next time.